So we have another one from integration. This is the last questions. These are the last questions. This is a paragraph again. So we have fx is sine square x from 0 comma pi by 2 to 0 comma 1. We have gx from 0 comma pi by 2 to, yeah, the positive real numbers, or the non-negative ones rather. We have gx is the root x times pi by 2 minus x. Okay, so moving on to the first one, 16th. So this is 2 times integration 0 to pi by 2 fx gx. So let's plug in the values. We have sine square x times under root x by 2 minus x, root x times pi by 2 minus x dx. Let's have a look at this one separately. So this is 2 times integration 0 to pi by 2. So instead we'll write this like this. So I think you have the idea what I am planning to do next. We'll make use of the fact that integration a to b f t dt using this fact, what we call as the King's rule, this becomes 0 to pi by 2. Sine square x becomes sine square pi by 2 minus x, which is cos square x. X becomes pi by 2 minus x. Pi by 2 minus x becomes pi by 2 minus pi by 2 minus x, that becomes x. And now when we'll add this with this factor comes out as a common, and we are left with pi by 2 sine square x plus cos square x times root so this becomes 1. So that is, so we have a nice thing here. This thing simply is this, which is equals to pi by 2 root x times pi by 2 minus x, which is exactly this thing. And this is this thing with a minus sign, so they get cancelled away. So without actually integrating, we simply get this thing is 0. So answer of 16th is 0. Which in turn gives us 2 times integration 0 to pi by 2 f g dx is pi by 2 g dx. So we'll make use of this fact for the 17th one. We'll, instead of evaluating 0 to pi by 2 f g dx, we'll simply evaluate 0 to pi by 2 g dx, which is 0 to pi by 2 root x times minus x dx. We'll make a substitution here. We'll replace x by pi by 2 comma say sine square theta, which gives us dx is pi by 2, it's rather pi, because sine derivative of sine square theta becomes 2 sine theta cos theta, that is sine 2 theta, or rather let's just keep it this way, sine theta cos theta. We'll get a 2 from here, and the 2 will get cancelled from this, and let's make the substitution. 0 to, so the limits will go from, yeah, still the limits would be from 0 to pi by 2. Root x is pi by 2 sine square theta. Pi by 2 minus x will become pi by 2 cos square theta. Cos square theta, and dx is pi sine theta cos theta d theta. So this is 0 to pi by 2. We have a pi by 2 sine theta cos theta times pi sine theta cos theta d theta. This becomes pi square by 2 pi by 2 and sine square 2 theta pi 4. I club these two together and these two together, multiply and divide by 2, making this 2 sine theta cos theta, that is sine 2 theta. So this becomes sine 2 theta by 2. Similarly, this becomes sine 2 theta by 2. These two comes out as 4. So let's pull this out as well. We'll get a 8 here. This goes away. And d theta. Let's multiply, divide by another 2 to make this 16 and this d 2 theta. So this simply becomes pi square by 16 times 0 to pi sine square theta d theta. This becomes pi square by 8, 0 to pi by 2 sine square theta d theta, and this value simply is pi by 4. This is a well-known result, so this becomes pi square by 8 into pi by 4. So for that we simply use this trick. I is equals to integration 0 to pi by 2 sine square, which is equals to 0 to pi by 2 cos square theta d theta by King's rule, which gives us 2i is integration 0 to pi by 2 sine square theta plus cos square theta, that is 1. Sorry, 2i is equals to pi by 2. So that's the value we have substituted here. So this gives us our answer is pi cube by 32. The integral value rather is pi cube by 32. Substituting it here, this was pi cube by 32, which gives us fx gx, sorry, fg dx is in this thing. So we get 0 to pi by 2 fg dx. So that makes our answer 1 by 4.